Let's take a look at Venn diagrams and how we calculate probabilities with the Venn diagram logic. So in this case, we're looking at rolling just one die, and we're trying to find the probability that we get a 3 or we get an even number. So we have to keep in mind a few different things here. We're looking at wanting to get a 3 or wanting to get an even. So there's kind of two different things going on here. So we're going to break this out into a Venn diagram and say, okay, when I draw Venn diagrams, I start with a box, and that box represents all the different outcomes that occur. And we know that when we roll a die, there are 6 outcomes. So inside this box, there are 6 different outcomes. Now, I'm looking at getting a 3, so I'm going to say, hey, you know what, I want a 3, so that's going to be one of my circles, a 3. And I want to get an even, or an even. So one of my circles will be an even. Now the most important thing when you set up your Venn diagram is to decide, do the circles overlap or do they not overlap? And in this case, the reason I know that they do not overlap is when I go up to my outcomes, 3 is one of the outcomes, even is another one of the outcomes I'm looking for. 3 and even can never happen at the same time. I could never get a 3 and an even number at the same time. So that means this is a mutually exclusive event. These things cannot occur at the same time. So I have 2 circles that are separated here. Now when I roll a die, there's only one way to get a 3, and that's if I roll the 3. There's more than one way to get even, an even number, and there are 3 of them. 2, 4, and 6 are all evens. So all the even numbers are in this circle, all the 3's are in this circle, and outside the circles are all of the other outcomes that could occur. That would be 1 and 5. Now, when we have mutually exclusive events, and we're looking for the probability that of these two things, this one or this one happening, okay, by the way, the key word here, do you see the key word? Or, and in statistics, in probability, the word or generally means that you're going to end up adding. So when we look at these kinds of questions, if we want the probability for mutually exclusive events, that means that the circles do not overlap. The 2 events cannot happen at the same time. Okay, all we need to do is basically add the 2 probabilities. So in this case, what we're looking for is the probability that we get a 3. There's only one way to do it. Out of 6 total outcomes, 1 and 6. The probability of getting an even, there are 3 ways to do it. 6 total outcomes, 3 out of 6. So when we look at this kind of question, we see the probability that we get a 3 or an even. And now I've switched the symbols on you, and no longer using the word or. We're using the symbol for or, which is this. It looks like a capital U in a sense, but it's a union. It's called union. You should add the probabilities. Okay, add the probabilities. And so below we said the probability of getting a 3 is 1 out of 6. The probability of getting even is 3 out of 6. We add the 2 together and our answer is 4 out of 6. So when we have exclusive events, mutually exclusive, we should add probabilities. Now, when they're not mutually exclusive, then we have to be careful. Because, I'm going to jump back here real quick. What we really did back in this example is we said, let's take the probability of getting a 3. We said, let's basically take this circle, and we said, let's add this circle. When we talk about probabilities, we basically said, let's find the probability of these 2 circles combined. That's basically what we did. If we use that same logic in this case, and we say, let's find the probability of the 2 circles. Let's take the 2 circles and add them together. Maybe you realize already that we're going to have actually a problem here. And the problem is going to be that I actually am going to be adding 2 different areas. I should say I'm going to be adding this area right here. I'm going to be adding it twice because it actually falls in both circles. I have to be careful. That means I'm going to be double counting some people. So I can't just add probabilities. I'm going to go back here. Okay, so we have to remember that if our circles are overlapping, if it's not mutually exclusive, We can't simply just add like we did last time, because this part of the circle falls, this part right here falls in both circles. We actually are double counting. So when that occurs, if it's not mutually exclusive, we have to remember to be careful. We are still going to add the two circles. That's what this part is, the probability of the first circle plus probability of second circle. We're still going to add the two circles, but then we need to subtract this part because we've added it twice. Okay, so we're still going to add the two circles, but we're going to subtract this area off, or this probability off, because we have counted it twice. That's the key factor in that kind of question. And again, I've switched the symbols. I've used the U or union here, probability of A union B, A or B. And we just need to remember, add the two probabilities, but make sure you subtract the part that overlaps. Subtract the part that represents both at the same time, because it will have been counted twice. So in my classroom, if I were to take a look at the probability, if I pick a student, that student is 11th grade or a male, I could basically follow this whole rule, and I could say, okay, let's find the probability that I pick an 11th grader. Let's find the probability that I pick a male, and add the two together. I have to be careful though, because there are some people in my room that are 11th grade and male at the same time, so they actually would have fallen in both of these categories, so I would have added them twice. So I need to make sure that I subtract them off once. I need to subtract off the people that are both 11th grade and male because I counted them twice. Again, that represents this yellow area up here in my diagram. So in my classroom, probability that I pick an 11th grader, well, I have 8 11th graders out of 39 students. Okay, the probability that I pick a male, well, there were 20 males out of 39 students in my class. So I would add these two together. Now I have to be careful. Since 11th grade and male, someone can be both at the same time, my circles are overlapping in this problem. So here I get 28 out of 39, but I need to subtract off the people that are both, because I've already counted them twice. There are 3 people in my class that are both 11th grade and male, so I would need to subtract those 3 people because they were counted 2 times in the other ones. So that would give me a grand total of 25 out of 39. So if I pick a random student out of 39 students in my room, there would be a 25 out of 39 chance I would pick somebody that is either an 11th grader or a male.